it says b. So if b is 2, what can we say?
That's exactly 2 digits. Then it'd just be like 1 0 1. These 2 digits sum to square root of n. So there are no good.
So 1 0 in base 2 is 2, right?
Yeah, which is no.
So this one is 2, this one is 3.
Yeah.
And a square root of, we know that the number should be a perfect square, right?
Yeah.
So here we don't have any beautiful number, right? Any beautiful number.
Yeah.
So what about b3? Let's check some small cases. So it's a start from what? From 1 0, right? In base 3.
Yeah.
All the way to what?
1
2 2 in base 3.
2. Yeah.
So this one is 3 to what?
This is 8.
Yes, we can say next digit is 1003, which is 9, right?
Yeah.
So for B, we should consider from what to what for general B? What's the first number? What's the last number?
1 0 base B, so just B.
All the way to?
B minus 1, B minus 1.
It's better to say this 100 in base B, right?
It's 3 zeros, right?
Yes, 100, which is B squared. So we should consider all the way to B squared minus 1, right?
Yeah.
So the problem is this. From B, if you write B to B squared minus 1 and write them in base B, in how many of them sum of the digit is the square root of B, right? Is the square root of n, right?
Yeah.
So if we want to consider B3, we need to only consider which numbers? The numbers that are perfect square, right?
Yeah.
So the only number from 3 to 8 that is perfect square is what?
Equals to perfect square is 4.
Yes. 4 is what in base 3?
1 1.
So it's the first beautiful number that we found, right?
Yeah.
Because some of the digits is the square root of that. So now let's consider, for example, so do you agree we should have at least 10 perfect squares, right?
Yeah.
So let's find the first B that creates 10 perfect squares. It means here we should have at least 10 perfect squares. So try to find the first B that creates 10 perfect squares, okay?
Okay. This one B equals 14.
The minimum B is 14.
Actually, I don't. Let me check if it's minimum though.
Okay.
Yeah, I think it is the minimum.
The minimum is 14, so if we consider B14, it would be from what to what? 14, 15, all the way to what?
Like the squares?
196 minus 1, right?
Yeah, 195.
It will be 195. So here we have 10 perfect squares. Let's check. We have 4 squared, 5 squared, 2, all the way to 13, 14, 13 squared, right?
Yeah.
Yes. And if we check, for example, let's check here B14. If we check 16 in base 2, it would be what in base 14?
12, 1, 2.
1, 2. But some of the digits is 3 is not equal to 4, right?
Yeah.
Okay, so we found that B is at least 15. Okay, but let's check other cases. Here, we have Y. So let's consider, for example, here we have X, Y in base B. We want to analyze under what case it would be a perfect square. Xy should be the square root of what in terms of xy and b? X plus y. X plus y
Yeah.
should be what?
X, Y. Um, X plus Y equals square root of BX plus Y.
Exactly. And this number is bx plus y. X is from what to what? Y is from what to what?
X and Y are from 0, or X is from 1 to B minus 1. Y is from 0 to B minus 1.
Exactly. Okay, so x plus y should be equal to the square root of bx plus y. Now let's raise it to the power of 2x squared plus y squared plus 2xy is equal to bx plus y, right? Okay, what should we do when we have this equation? The idea here we use is useful also in HMMT, Harvard MIT Math Tournament, Team Brown. There was a hard problem. I will tell you the problem. So when we reach an equation like this, what should we do?
Not sure.
One good approach, we use this also for when we had a floor integer part, fractional part, remember?
Okay.
I told you, for example, write x as this one plus this one. And then I said, okay, constant integer part is k, fractional part is r is greater than 0, less than 1. We solved AMC and AIME. In all of them, you should do something. That idea is exactly the idea that we should use here. What was that idea?
Okay. How does that apply here, though?
You should do what?
How does that apply to this one?
No, you shouldn't apply this one. For example, look, when we wanted to calculate r, usually we calculated a quadratic, we had a quadratic formula equation, then we use a quadratic formula, okay?
Okay.
And then here we should use the same idea. Here the agree is a quadratic equation in terms of y
Yeah.
plus x squared minus bx is equal to, right?
Yeah.
So what's y equal to?
Y is equal to negative 2x plus 1
Yes.
plus minus square root of 2x minus 1 squared minus 4 times a times minus 4 times x squared minus bx
Yes.
over 2.
Yes, so you should pay attention to two things. Here, this should be a perfect square, and this summation should be multiple of 2, right? And also, we should pay attention that this one should be between 0 and b minus 1, okay?
Okay.
So, one thing that is important that we can conclude here, let's simplify first, and then we can say, obviously, we should select plus, because if we select minus, it would be negative, right? But let's simplify this one first. Y is equal to negative 2x minus 1. What do we get if we simplify the terms inside the square root?
So 4bx minus 4x plus 1.
Because 4x squared will cancel each other out. 4bx minus 4x plus 1 over 2, right?
Yeah.
Look, if this one be a perfect square, yeah, I mean, it would be good because it is odd. If it's odd, then it would be multiple of 2, right? Because it should be integer between 0 and b minus 1. So we don't have problem with this over 2, right?
Yeah.
And also, do you agree we should select plus? Because if you select minus, x is between 1 and b minus 1. So this one is at least 1. So if this, and we know this one also is at least 0, right? And this one cannot be 0 because it is odd. So this one is at least 1 if it is integer. So if you select minus, do you agree it would be bad? Because then this one is negative. This one also would be negative. Negative over 2 will be negative. It should be integer between 0 and b minus 1, right?
Yeah.
So we should consider plot sign. Now the only thing that we should pay attention is to find all values of B, that there exists how many values? 10 values. It says we need 10 beautiful numbers, right? There are more than 10. We need at least be beautiful numbers. So we should find these that we have at least 11 x's to be perfect square, right?
Yeah.
So 4bx minus 4x plus 1 is a perfect square. And okay, so we don't need to work on y anymore. X should be at least 0 to b minus 1, right?
Yeah.
Okay, so let's check, for example, this beautiful number that we found.
Wait,
We
x is from
found,
1, right? X is from 1 to be minus 1.
yes, sorry. X is from 1 to b minus 1. So we found a good, beautiful number 4 in base is 113, right? So in this case, b
Yeah.
is 3, x is 1, y is 1, right? So when you cancel xy, it would be 4 times 3, 12. 12 minus 4, 8 plus 1, 9. It's a perfect square, right?
Yeah.
Okay, so this number is a perfect square. So want to try this one on your own to see for what values of b and x is perfect square, or do you need a hint?
I can try.
Okay, sure.
I'm not sure how to do it.
Okay, so here we know it is a perfect square, right?
Yeah.
So how can we write it as a perfect square?
Well, you said it equal to m squared.
Yes, but we know this is not any perfect square. It is what perfect square?
An even perfect square.
It's even. Pay attention.
Oh, perfect square divisible by 4.
This one is even. This
Well,
number is
no.
even.
No.
It's
But
odd, right?
yeah, odd.
So we can write it as what square?
Uh, 2m plus 1 squared.
Exactly. Then what can we conclude? We can say 4n squared plus 4n plus 1. Then what?
Then you can get bx minus x equals n squared plus n.
Yes. So we can say x times b minus 1 is n squared plus n, right?
Yeah.
Okay. So here we can use a small example, right?
Yeah.
For example, what we proved that B14 doesn't work. For example, let's check B15. Okay, we can check B15 or 14 or any of them. So if B is 15, we should find at least 11 good x's, right?
Yeah.
And we know x is at least 1 less than or equal to 14. So let's check. It would be 14x equals n times n plus 1. I remember we solved a problem, something like this. 168p plus 1 is a perfect square. Do you remember some problems like these? I told you, I think, around
Yeah.
8
Yeah.
months ago. And we said it is x squared, then odd perfect square. Then we cancel that and we said k times k plus 1. We should use exactly the same thing here. Uh, when 14 is what is one of them, these two are relatively prime, right?
Yeah.
Okay, but x is not necessarily prime, right? For example,
Yeah.
let's check for 14. For this case, try to find all possible values of x, okay? For only this.
Okay. N
Mm,
equals 7 and n equals 7 and n equals 6.
okay, so what are all possible values of x?
Wait, actually. Uh, so possible values of x are 4, 3, and 13.
4, 3, and 13, you said?
Yeah.
Okay, let's check. Here we know that x is at most 14, so when you multiply, n is at most, if it is 14, then it will be 14, 15, at most 13, right?
Yeah.
This one at most 14. Okay, so because this one n times n plus 1. And here also we can say the same thing. We know x is at most b minus 1, right?
Yeah.
So if you consider some b minus 1, it would be b minus 1 times b. So n is at most b minus 2, right?
Yeah.
Like this one, b15. Okay. And this one at most b minus 1. So 14x, if we consider 14, we should distribute 14 here. This one is multiple of 14, or this one 14, or this one 2, 7, if this one is not multiple of 14, or 7, 2, right?
Yeah.
We can reject this case because it's at most 14, but if this one is 14, this one is 13, in this case x is 30, right?
Yeah.
For this one, it is 7 or 14. It is multiple of 7. So what 14? We checked 14. So let's consider only 7, right?
Yeah.
So this one is 7, this one is 6. So 14x is equal to 6 times 7. So x is equal to 3. Good job. So we found this one, this one. And for this one again, you cannot say 7, 14, right? Because we said it's impossible. So it should be 7. And it should be multiple of 2. So we can say 14x is equal to this one is 7, this one is 8, right?
Yeah.
So x is equal to 3 divided by 2, 4. Okay, good. So we found two beautiful numbers, right?
Yeah.
So if you want to increase number of x's, can you guess what should be satisfied about b?
B minus 1 should have like a lot of divisors.
B minus 1 should have a lot of divisors, right?
Yeah.
Because b minus 1, for example, if b minus 1 is prime, obviously it is not good, right?
Yeah.
Okay, so try to find, look, now, if you were not x at most b minus 1, try to see if you can find a good b, right? For example, obviously we can say, for example, b minus 1 is equal to, for example, different numbers. 2 to the 10, or for example, you can distribute, see if it's better to increase the power, or, for example, multiply with power 1 or power 2 or something like that. Try to find a good b, okay?
Has like 10 x values.
At least 11 x values, okay?
Okay.
And then we try to minimize. Try.
I think when b minus 1 is 210, it has enough. So I did.
Uh, when b minus 1, yes. Because, look, the powers are not good. Because, for example, if, for example, this one is 2 to the 100, you cannot distribute 2 between these two, right?
Right, because I want them to be
Number of
relatively
primes
prime.
are more important. And if it has, for example, if b minus 1, for example, has t prime factors, t distinct prime factors, then you can use each of them here or here, right?
Yeah.
Then how can we prove that we need at least 4 prime to say 210?
I didn't prove that. I tried doing it with 2 times 3 times 5, and it couldn't get enough.
If you use 3 primes, what about that? For example, if b minus 1 is 2 times
Well,
3 times 5, why it's not enough?
I tried 30. I tried 30 and couldn't get enough solutions.
But what about other product of 3 prime numbers?
Like 2 times 3 times 7.
Or 3 times 5 times 7?
I didn't try that.
Okay, can we find a general proof for that? 2 primes are obvious that is impossible, right? Because look,
Yeah.
for example, when for this one you say b minus 1x. For 30, when you want to distribute, you can say, okay, this one is 2, this one 50. Or if we check, for example, 30 or 30 here, right? Or
Yeah.
this one multiple of 2, multiple of 15. Or we want to find a general way to reject, right? Because Maybe this, for example, 5 times it's 11 times 2. There are a lot of cases to check, right?
Yeah.
Okay, so if you check 15 to 215, what else?
15
How
to
many cases do we have? Can you say without writing all of them? If you write like this, 130, 31,
8.
8, you said?
Yeah.
Yes, because you should consider a subset of this, right?
Yeah.
So we have 8 cases, but we need how many cases? 11 cases, right?
Yeah.
So 3 primes are not enough, right?
Yeah.
And because we need 4 primes, b minus 1 should be 2 times 3 times 5 times 7, which is 210. We should check b 211. Have you checked 211 to see if we have 11 good cases?
Well, I checked. I found 11 good values of n.
You found 11 good values for n and x, right?
Yeah.
Okay, and the problem wants us to find only minimum b, so b is 211, right?
Yeah.